Visual interpretation, a study of third-angle projection used in the United States and first-angle projection used by foreign countries. Hello, my name is Tom Vanderloop and I'll be your instructor for this particular session. And what we're going to do is we're going to investigate the difference between the visual interpretation of third-angle projection, which is used in the United States, and first-angle projection, which is used in the foreign countries. To better get a feel for what first and third angle projection is, we'd better take a look at a drawing or a blueprint to get a feel for the first angle and the third angle projection. The drawing on the screen is a drawing from Nelson Industries, and if I zoom out on it, you can see we've got a view, detailed view here of a part, and the detailed view of the part you can see is a regular orthographic view or an orthographic drawing. We've got a round stamping, and then that stamping identifies the geometry of the part. And we can zoom in on this drawing, and immediately you can see there are symbols in the title block that we identify as third angle projection. And there's the symbols right there. Third angle projection. We've colored it in with a yellow marker so you're able to see third angle projection. And Nelson Industries in Stoughton, Wisconsin is one company that manufactures stampings, and their stampings, of course, are illustrated in third angle projection. Another company quite common to the Midwest here is Hutchinson Technology, and Hutchinson Technology also in their title block puts the symbol with the two concentric circles and the cone to use for third angle projection. Now, the United States, we have elected to use third angle projection as the two concentric circles and a cone. And in foreign countries like Germany and France, they use first angle projection. And first angle projection, you've got the cone, you've got the two concentric circles, and what we really have is we have a Cartesian coordinate system that we work with whenever we work with first angle and third angle projection. And the Cartesian coordinate system might look something like this, where we actually show what a Cartesian coordinate looks like, and here you are able to get an appreciation for the system. You can see what it looks like, and the Cartesian coordinate system is broken down into an x-axis, a y-axis, and then right here in the center now we have a 0 point. And that 0 point is like an origin or a beginning of the planes that we have. Now you can take these planes, you can line them up, and you can actually create what we call 4 different quadrants. And you can see all 4 quadrants illustrated here. Let's slide this up a little bit. And the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant are illustrated. We don't use the second quadrant in engineering graphics, and we don't use the fourth quadrant in engineering graphics. But we do, in the foreign countries, use first angle projection, and in the United States and North America, we use the third quadrant, or what we call third angle projection. The easiest way to imagine first angle projection and third angle projection is probably to begin with what we use in North America. And if we take a look at the concept of what we call the glass box, we have a normal glass box arrangement, and you can see what that normal glass box arrangement looks like. We have the observer, we have a glass box in the third quadrant, and then we have the object on the inside of that glass box. The reality is we can take any object and we can enclose it inside of a glass box. We can call ourselves on the outside of the box the observer. We can call the glass itself the third quadrant, and we also can call it third angle projection. And then inside of that box, suspended, is the object. So we've got the observer, the glass planes, and then the object. In third angle projection, the glass box is referred to as orthographic projection, and you can see the observer, the third quadrant, the front, the top, the left side, the right side, the bottom, and then of course on the back we've got the back or the rear. And these then are the 6 normal views that we work with in the third quadrant. The third quadrant would actually work similar to what we have here, and you can see what we have. We have a front view, and there's our front view, and the front view is projected to a pane of glass, so therefore out here the yellow pen represents the observer. The glass would be next, and then the object is put inside of the glass, and we've got what we call third angle projection. The top view is brought directly to the top, and you can see what the top view looks like. The top view has got this feature, which is an oblique surface, and you can see that oblique surface. And then on the right side view over here, you can see we've got the observer, we've got the glass pane, and then you've got the object here, and the object here is going to be represented in a right side view, and that right side view is going to give us a hidden line or a hidden feature for that oblique geometry. And so therefore we project that object. It's square or rectangular. We project it, and if you had X-ray vision, you'd have to look through the object, and therefore you get the hidden feature or you get the hidden line. This then gives us the 3 views. We get a 3-view arrangement where we have in third angle projection a front view, a right side, and a top view. So that's third angle projection. Most engineers that I've worked with over the years that came to North America from other countries that used first angle projection admit that third angle projection is much more logical and much more reasonable to use than what we call first angle projection. However, first angle projection is used in France, Germany, and a lot of the other industrialized nations of the world, so we have to put some credence in what first angle projection is about also. First angle projection would look something like this. With first angle projection, we've got the observer represented again by the yellow pen. We've got the object, and then from the object we project to the glass planes that are in the first quadrant. And when you represent that in the first quadrant, you're looking at a representation like we see here. And when we work in the first quadrant, we're actually putting the object here and then projecting it down to the glass plane, projecting it over to the glass plane, and when you're in the first quadrant you can see how the top area right here becomes the bottom, and how the right side over here, as we're looking through, becomes the left side. So this right over here now becomes a left side, when indeed we would call it a right side in third angle. And then the front view is projected back, and that'll pretty much stay as it is, intact as a front view. And we project from the observer to the object, to the glass plane, or to our frame of our Cartesian coordinate. And you can see we're working totally here in the first quadrant. So when we look at the two systems, the front view really doesn't change, but the top view that we'd have in third angle becomes the bottom view in first angle. That's this right here. And then the right side that we'd have in America becomes the left side here, and we call it right side. And the front will be the same in both views. So when you put them side by side, you can see what changes and what doesn't change in terms of the recognition of the views. The right side and the left side change. So in America, this stays as the right side, this stays as the top, and the front. And you can see that in America, with third angle projection here, it's very logical. In foreign countries, you must take the right side, you must put it over here at the left, and you must take the top view and you must put it down here at the bottom. So you can see the difference between the two systems. I think if we use a graphic and we compare the two systems, a good graphic might be what we see here, and that is the third angle projection that we use in the United States. We establish a front, we establish a rear, a right side, a left side, a top, and a bottom, and we see a lot of logical geometry. In third angle projection, when we look at it, the top becomes the bottom becomes the top, the right side becomes the left, and then the left side becomes the right side. And these four views that are colored are just these four views put into different positions. And therefore, they're working in the first quadrant with foreign projection, and it looks somewhat foreign, doesn't it? And this is more logical, this is third angle projection, and that's pretty much what we use in the United States. Two things to remember. In the United States, we have the observer, we have the glass box, and then we have the object enclosed inside of the glass box. So in the United States, when we look at the glass box and we review the geometry, we have the observer on the outside, we have the glass box between us and the object, and this then becomes the three important points about third angle projection: the observer, the glass box, and then the object. With first angle projection, the thing to keep in mind is, with third angle projection, we've got the observer, we have the object, and then we have the glass box, or we have the panes of glass that we project from the object directly to the first quadrant. From the top, that becomes the bottom. From the front, that becomes the front. And then our right side over here becomes the left side, and therefore we get an arrangement a little bit different than we might anticipate with first angle projection or foreign projection. We put the cone first, the concentric circle second, and these four views then are the four that would be changed or moved. The bottom was originally the top here was originally the bottom, and then the two left and right sides both change. We will stay in America with third angle projection because third angle projection, for a number of good reasons, is quite logical. We have the observer on the outside, we have the glass box or panes of glass that follow, and then on the inside of the object we have the actual object that we are viewing or that we are drawing.